Good morning. Today we're going to review how we build training data sets in the Lucd application. In particular, we're going to be focusing on two primary data sources, Amazon.com movie reviews and movie reviews from the imdb.com data set. First step in that process when I log into the Lucd application is to visualize what data I have access to in the environment. I can see here that I have four primary data sources. There's Amazon and IMDb. And I can also visualize time series information if there is any for either of those data sets. So then here I can begin to zoom in and see what the cardinality of the data set is. I can zoom in and see if there are any gaps in the data and see how that data changes over time. When I'm ready, I can come into the Data tab and begin to query across my data sets. I can query by source if I so choose, selecting one or more sources. I can query using Lucd query capabilities and a Boolean query. I can specify date filters, Boolean logic, the number of records to return, the number of records to return per source or model if I want to control how many come back from one data set versus the other. I can also choose whether or not I want to randomize the results, which is something I would naturally want to do for machine learning. The Lucd application provides two additional ways to query across the data. I can query using facets and applying filters in accordance with the data models within each of the data sets. So the IMDb movie review is a very simple data model. It only has the review text and a sentiment. The Amazon reviews are a little bit more verbose in terms of providing a reviewer name, timestamps, and other information. Finally, I can search using a conceptual query, typing in a term that would be related and then extracting different terms in my text data sets that relate to that based on some distance calculation. Here we're going to be focusing on just a simple Boolean query. We're not going to limit it to a given source. I've actually pre-executed the query so that we could see some of the statistics that are returned by the system from the query analyzer. When I look at the Amazon.com reviews, for example, I could see a very simple description of the data frame that's being built in the data center as I execute the query. So then I could see the distribution of the overall rating, which is the primary feature that we would use to indicate sentiment for a movie review. Amazon.com has 5-star reviews, 1, 2, 3, 4, 5. IMDb has reviews that are indicated as either positive or negative. I could see here, for example, there are in fact gaps in the data. I asked for 5,000 results to be returned and in fact only received 4,934 for this particular feature. You can see it's stored as a float. I could see that the majority of them have a mean of 4, so the majority of the reviews are going to be positive, or either a 4 or 5-star review. I could see this for any of the distributions for the features in my data sets, and then I can come in and look and see what the distributions look like. The system automatically already knows what the data features types are. It's already extracted those through a background analytic that we've executed against the data, and using that metadata table, we're able to automatically describe that data appropriately. Look at the movie reviews from IMDb, and we could see, for example, the sentiment here is either positive or negative. Most frequently, it's positive. But that's stored as a string, so I'm not going to get the same type of distribution statistics that I would get otherwise. The next step in the process is to visualize the data to begin to understand what that data looks like. The Lucd analytic enables me to be able to plot the data in 6 different ways. The first approach is to simply come in and visualize the data as a scatter plot. We're doing that in 3 dimensions here. The orange dots represent the actual data points themselves. I can click on an orange dot and I can get a summary of what that data looks like. And when I click on the magnifying glass, I can pull up an individual record and see what that looks like. So this is my free text message here, movie TV review.txt. and that's what we're going to be processing today. You can also down here change some of these settings if I wanted to see the mover reviews broken out by their ratings. I can distribute them on the time series, and then I can also get a distribution of those using the text segment itself. And when I do that, then I can see what the distribution of data looks like across each of the ratings. So here on the left-hand side, you have 1-star mover reviews, and then on the right-hand side, I have my 5-star mover reviews. If I wanted to, I could begin to actually filter this data in the data center. What's happening as I go through the user application is I'm actually building a large-scale distributed data frame in the data center, in this particular case in our SaaS environment in the cloud. And so then I can begin to do things like apply filters. If I don't feel like I have enough 1- and 2-star mover review data, I can filter this down very quickly and easily to the 3-, 4-, and 5-star reviews. I can also visualize the structure of the data using the parallel coordinate plot. Very quickly, what I'm able to see here is how the different data features in my query data set relate to one another. For example, I can see here with the movie TV rating overall, I have what looks to be a categorical feature. And when I rotate this in 3 dimensions, I can begin to see, for example, that this unique ID, this ASIN ID, does in fact contain a couple null values. In addition to that, there are some null values over here on the movie TV review time. So this is already beginning to give me a sense for what type of filling I may need to do if I wanted to use those particular features. I can visualize the data as a series of histograms. One of the things that you'll notice is that, again, the system automatically knows what form of the data is, what the type information of the data is, and it's capable of displaying the data automatically for me. So from a machine learning point of view, from a data scientist point of view, I don't have to focus on opening up a notebook and knowing how to use matplotlib in order to be able to plot my data. I can do that immediately on day one with this tool. And in fact, a major focus of ours at Lucd is, in fact, to be able to make the tool available to people outside of that machine learning group that most enterprises have. Our focus on collaboration means that you're able to bring in subject matter experts, data experts, business process experts, division managers, line workers, etc., to the process of creating AI for your organization. In our opinion, if every company is to become an AI-enabled company, that really implies that every worker then has to become an AI worker. We could do the same thing for box plots, and then finally we can visualize a Pearson correlation for the data, which gives us an indication of which parameters are most highly correlated to one another. So then I can see all of that information there and begin to build an idea and an understanding of what the underlying data sets look like. The final step in the training data set process is then to begin to manipulate the data. I've noticed that there are some gaps in the data, and as well, those gaps are really occurring because these 2 data sets don't really overlap very much. So what I'm able to do in the tools, I'm able to very rapidly build additional transformations over the data sets. What I'm doing now is I'm just bringing in a couple different series of transformations. What I would normally do is down here on the bottom, I would add my search to the workspace. That's represented down here by the bubbles that indicate IMDb only and movies for Wesley Snipes. And then I can proceed to apply additional operations to that data to accomplish pretty common data tasks. Again, no coding required, no knowledge of Python required, no knowledge of back-end machine learning libraries are required in order to be able to do these things. You simply need to have an understanding of what the data is and how you might be able to manipulate it. So let me illustrate what it looks like to add a new operation to the data. Here I have on the left-hand side my standard operations. These are the things that data scientists execute most frequently. There's filling of empty values, dropping of empty values, dropping duplicates, replacing data values, masking and filtering the data. I can join across data sets, and in fact, I can join across these trees if I wanted to incorporate multiple searches into my data. And then finally, I can fuse across the different data sets. When I fuse, what I'm doing is I'm basically choosing the features that I want to fuse together and bringing those together into a new column name. I can also apply natural language processing operations to my data. And what this enables me to do is it enables me to build a pipeline with kind of the common set of operations that you might do. So very quickly, simply pop these on. I can move them up or down if I want to change their order. I could choose the entities that I want extracted from the data. And then finally, I choose the column of the data that I want for processing and whether I want to do document or sentence tokenization. When that's complete, I save my data set to the workspace right here. I can say save my virtual data set. I give it a name, a description. Here I can choose the features of the data that I want to use for my input features to the model training. And on the right-hand side, I could choose any of the features of the data that I want to use for labels.